Alright, this was a test that I gave my class on quadratic functions. In this video, we are going to focus on using the quadratic formula to solve quadratic equations. And we'll probably get to look at quadratic inequalities as well. Alright, which equation could we use to solve 0 equals 4x squared minus 3x minus 2? Obviously, we're talking about the quadratic formula here, and the quadratic formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is pretty straightforward, since here we see that a is 4, b is negative 3, and c is negative 2. Then this becomes opposite of b, so that's positive 3 plus or minus square root b squared, so that would be negative 3 squared minus 4 times negative 2, alright, all over 2a, so all over 2 times 4. So this would be the setup of the entire quadratic equation. So I see the negative 3, so right away I throw those out. Now let's see, positive 3 plus or minus negative 3 minus 4. It was looking good until I got to this. It says positive 2, but it should be negative 2. So that leaves D. So I'll just scan across. And sure enough, there it is. So the answer is D. Okay, great. Great. What is the solution to this equation? Well, once again, let's use the quadratic formula. Now, it is our tradition to use to find the discriminant first. The discriminant is the b squared minus 4ac part of the equation. I'm singing because we know a whole song for that, but I'm not going to bore you with that right now. So a is equal to 3, b is 1, and c is 1. So we like to find the discriminant first. So the discriminant is b squared minus 4ac. So that'll be 1 squared minus 4 times 3 times 1. Okay, so that's 1 minus 12. So that's negative 11. Okay, then we go ahead and do the rest of the quadratic formula, where we say that x is equal to the opposite of b, so that's negative 1, plus or minus the square root, and we already did the b squared minus 4ac, so that's negative 11, all over 2a. Well, 2 times 3 is 6. Alright, and when we see a negative underneath the radical, we know that that's going to come out as an I instead. So this is going to be x equals negative 1 plus or minus I radical 11 over 6. And looking in this area, there's nothing to be reduced or anything, so this is the final answer. Okay, so I'm scanning, and it's B. Alright, what's the solution to this inequality? Now, lately we've been doing this with a graph, and I don't see any graph paper here, so let's see if it'll factor. As long as it'll factor, we can draw our own graph pretty easily. So let's try to factor it. Alright, so we've got 2x squared can only factor as 2x and x. 21, you know, probably 3 times 7, or 7 times 3. Okay, so let's play around with that. Inner, we have 3x. Outer, we have 14x. Alright, so we know that inner plus outer must equal the middle. So can I get negative 11x out of this if I pick the signs right? Sure I can. If I have a negative 14 and a positive 3, that'll make negative 11. So there's my positive 3x. This will make my negative 14x. Does that give me negative 21? Sure it does. Positive 3 times negative 7 is negative 21. So we have now factored it correctly. The point of this is to find the zeros, or the x-intercepts of the function here. So if I set these equal to 0, so 2x plus 3 equals 0, or x minus 7 equals 0, that'll give me the zeros of the function. So I'm subtracting 3 from both sides. That'll give me 2x equals negative 3. Dividing by 2 on both sides gives me x equals negative 3 over 2. Now as I'm glancing at this, I see they have decimals. So, you know, I know that this is negative 1.5. So there you go. If you did not know that for some reason, you could just use your calculator. Alright, and I could toggle it to get the decimal out of it. So yeah, negative 1.5. Anyway, now looking at the other one, if I add 7 to both sides real quick, I get x equals 7. Okay, so 7 and negative 1.5. So clearly that's where they're getting these like numbers from. Okay, but we need a graph to go with this. Let's see, do I have space over here to do a graph? Yeah, let's do a graph over here. Okay, so let's make our own graph real quick. If let's say this is 0, and this will be our negative 1.5, and this will be our 7 over here. Okay, notice there's no y in this, so this is not a shading graph. This will be a number line graph. Okay, that's important to note. So let's see what else I want to do here. Open circles or closed circles? Well, you see the or equal to part, so these zeros represent where the function is equal to 0. We want to include those, so we'll do closed circles. Okay, now let's draw this parabola. It's quadratic, so we know it's a parabola. You see the positive leading coefficient, so you know it's going to be an upward facing parabola. So it's going to be something like this. Kind of missing here. Let me try that again. I said we know it's going to be an upward facing parabola, so it's going to be something like this. Okay. Now for these number line graphs, we highlight. So we would ask ourselves, what part of the graph represents the solutions? Okay, now we want the part of the graph that is equal to 0, alright, see the little equal to part, so I'll include the endpoints, or less than 0, okay, less than or equal to 0. So the less than part means below the x-axis, so we want this part. Okay, now if I were going to look at this as a number line, as we often do I want the part of the graph, are we talking about the part of the number line that's between negative 1.5 and 7, or the part of the graph that's outside? Alright, in other words, do we want this part? Are these the solutions? Or are these the solutions? Okay, which is it? Hopefully it's obvious that it's the second option. Alright, these solutions here are between negative 1.5 and 7. So here it is in number line form. Okay. Now normally we would do interval notation for this. So we would say, oh, check it out, negative 1.5 comma 7. Alright, from negative 1.5 to 7. But I'm looking at the answers here, and they're not giving us interval notation. They're giving us inequality notation. Okay, so we want the inequality version of from negative 1.5 to 7, and that's going to be C. This is the inequality way of saying x values between negative 1.5 and 7. All right, you literally put the x between negative 1.5 and 7. Okay, there you go. That's how you do number 3 without graph paper. Okay, how about number 4? Which of the following equations has two imaginary solutions? All right, the grammar's bothering me. Well, you know how we always do the discriminant when we're about to solve by the quadratic formula. Our b squared minus 4ac. Yeah, let's do that, because the discriminant will tell us if there's imaginary solutions. Remember, if the discriminant is negative, you know we've got two imaginary solutions. So let's check our b squared minus 4ac for each case. Okay, so for a, b squared minus 4ac would be 3 squared minus 4 times 2 times 4. Oh, right off the bat, we got a negative answer. So that means two imaginary solutions right there. A is the answer. All right, just for fun, let's look at the second one and see how it won't give us a negative value. Okay, so yeah, that was the answer, because that gave us negative 23. Two imaginary solutions. Look at the second one. I'll change colors. The second one would have been negative 3 squared. Okay, that's b squared minus 4 times negative 2 times 4. Okay, so that would have been negative 3 squared. Whoa. Okay, let me start over. That would have been negative 3 squared. Okay, minus 4, and what is it? Negative 2 times 4. Okay, times negative 2 times 4. And that would have been a positive number. So the rest of these would have been positive or maybe 0. But this is the only one that will give us a negative, because that's two imaginary solutions. Okay, so that's the answer number 4. Number 5. Which of the following statements is false? Alright, which one is false? Well, let's check it out. First of all, let's subtract 8x from both sides to put it in standard form. So that'll be x squared minus 8x minus 20 equals 0. That's standard form. So we're looking for which one of these is false. Now, the discriminant is positive. Alright, we could just calculate the discriminant. One possible solution is 10. We could plug it into our calculator and see. X-intercept is negative 2 comma 0. Again, we could plug this into our calculator and see if it's there. Wait a minute. The equation in standard form is x squared minus 20 minus 8x equals 0. Well, that's immediately false. We don't have to do anything to tell that. In fact, just because it's what we always do, we put this in standard form. The negative 8x goes in the middle. So we don't need to bother with the rest of it. The answer is D. D is false. Okay, but just to be thorough, as a teacher, an educator, let's go back and look at the others and see why they are all true. The discriminant is positive. So the discriminant is that b squared minus 4ac. Okay, so the discriminant would be b squared, so negative 8 squared, minus 4 times 1 times negative 20. So there you go. That's what it would look like. And positive 144. Okay, so the discriminant was indeed positive. Okay, so one possible discriminant is positive. So that one was true. So I'll just put a true on that. That one was true. We're looking for the false one, so that wasn't it. One possible solution is x equals 10. Alright, well, let's put the equation in our calculator. And if 10 is a solution, then 10 will make a true statement. In other words, if we plug in 10 for x, okay, we should get 0 for the answer. Okay, 10 comma 0 is another way to look at it, alright, if 10 is a solution. So look at your calculator, hit your table button, type the equation in. Okay, if you want to be slick about it, start at 10, since that's what we're interested in. Oh, look at that, 10 comma 0. 10 is a solution. So again, that's why that's another true statement. Okay, one possible x-intercept is at negative 2 comma 0. Again, we can just look at the table and see if negative 2 comma 0 is there. Okay, so we'll just scroll to negative 2. Well, almost past it. Negative 2 comma 0, there it is. So that means that one's true. So again, they were all true except for D. So D is the false one, which makes it the answer. Alright, so we've done this entire first page. At this point, 17 minutes in. That's long enough for one video, wouldn't you say? Alright, so we'll pick up the second video with number 6, the second page. This is a 4-page long situation. Maybe I'll make one video per page. Let's see how that goes. Alright, page 1. Video done. I'll see you on the next video for page 2, which looks like this. See you on the next video.